Okay, this is all section 2-4. I'm going to start with questions 1 through 4. So question 1, we have a continuity in one side of the limits, and we're trying to figure out, let me see if I can pull up the question here. So we have, okay, so they're giving us for number 1, this particular graph. It goes through the points 4, 3, and 2, 0. It's a straight line. You can see that they're focused as for the value for C equal to 4. And we're going to analyze this from the right side, because remember the plus side says that we're coming from the right. The C minus, or the C with the negative on top, means we're coming from the left. And the limit of f of x as x approaches C, we're looking at the actual value at 4. So in this question, when you, as you draw this question, I guess, you should, let's see if I can do this with a straight line. So we're trying to draw this so that you can see the big picture, and this way I could trace it and you can see it on the actual diagram. Okay, so we're looking at this diagram here. This is question number 1. We know that it goes through 4, 3, so 1, 2, 3, 4, and up 1, 2, 3. So we definitely know we're at this point, and it definitely goes through 2, 0. So we'll draw a straight line through here, and this is what it looks like. So we are looking for 3 things. The first one is asking us what is happening from as we're moving in this direction. Because of the notation, this is where it says the limit, and then you see it's as x approaches C, and it has a little plus sign up here. So we're going this way. We're going from the right, coming this way. So from the right coming this way, as I approach this number here, the 4 positive, you can see that my actual, let me see here, my actual cutoff is at y equals 3, because this is 3, 2, 1. Alright, so here we have x is 1, 2, 3, and 4. Okay, the second part B asks us to look at the limit as x approaches C, and then it has a little negative up here. So in essence, we're looking at it coming from this side. Looking at it coming from this side as x approaches a C, and C being 4, you can see that again, we're looking at the value of 3. So your answer would be for both of these. So for this one, you would say the limit as x approaches, and in this case, the constant, which I'll write it out as should be. So you have the limit as x approaches 4 from the right side for the function f of x, in our example, is 3. So that would be your answer to part A. For part B, very similar to this, you would say the limit as x approaches 4 from the negative side, that for f of x, in our case here, is also equal to 3. So this answer is part B. So there's part A, there's part B. And now for part C, this basically says the limit, or part C, the limit as x approaches 4, and notice it has no designated right or left. So in this case, f of x is equal to 3. So that would be how you would approach question number 1 for section 2-4. And the idea is, because there is no interruption, you would say that this function is continuous. If you notice that there is no hollow point on the straight line at all, no hollow point, so there is nothing to say that this is anything but continuous. So you would answer the function is continuous at x equals 4 and is continuous on and then we're going to use negative infinity and positive infinity. Always use parentheses when you use infinity, by the way. Never use a bracket, because infinity is never limited. Okay, so let's look at question number 2. Let's go back to the book. Oops. Alright, so there's question number 2. And so you notice in question number 2, we're going to answer the same 3 questions here. We're going to look at it from as x approaches the c from the right side, as x approaches c from the left side, as x approaches c regardless. So we're looking at the value of -2. So c equal to -2 specifically. So so the two major points here, let me write these down for my own. So -2, 2. And we're going to use a point 2, 0, and it looks like it goes through -1, 0, and 1, 0 on this side. Alright, so let me redraw this over here. So let's recreate this here, question number 2. Okay, so we have here's our coordinate plane. Alright, so we're looking at -2, 2. So -1, -2, -1, -2. So this is a low point. This is another intersection point. We also intersect up here. It looks like 1, 0 is another point as well. And what else do we need for this drawing? It's going through -3, 0. So this is going back up this way. So continuous, so it's going like this. Okay, so those are the main points that we need to look at, but more specifically the -2, because our c equals -2. Okay, so from the right I'm coming from this side of the graph over all the way to -2. So in this case we would say the limit as x approaches -2 from the positive side, so in other words, not from the positive but plus, so from the right side, we would argue then that this value is -2. So our value here is -2 as well. From the left hand side we have, and this answers part A by the way, for part B we have the limit as x approaches -2 from the left. Alright, so in this case from the left, same thing applies. So from the left we see we're just tracing along, and again, same thing. We end up with a value, notice I'm back on the yellow line, we're back at -2. And lastly, for part C simply says what is the limit as x approaches positive, or just plain old -2, excuse me, from either direction, just the value itself. And so again, this also gives us -2. So we will conclude that this function is continuous at x equals -2. Okay, so you can see that there is no open area, no open dot indicating that there is a value that is omitted or whatnot. It's not like there's what we would consider, you know, an open point. These are all filled in, indicating that these are all possible values. Okay. Let's go to question 3. So looking at question number 3, and in question number 3, you start to see that open dot right there? And you see right here that this It jumps up, and now it's full here, and now you have 3 1s. So this is inclusive here, but not here. So in your notes, it was designated that this is one of the conditions where we know that this is not a continuous function at this particular value. So if we're looking at this graph, when I'm looking at just 3, you can see my cursor moving here. And as I'm moving from the right towards this number, towards 3, you can see that at this point my value would be 3, 0. So my answer for this would be the limit as x approaches 3 from the right is equal to 0. For part B, you see my cursor over here, I'm moving from the left. So from the left, at this point, you can see that I am reaching again where c is equal to 3. However, this value being 0 is not continuous. And then lastly, as x approaches 3 overall from either direction, it just approaches 3, we could see in this case that the value is still 0. So our response to this is the function is not continuous at x equals 3. Okay, so that would be your answer for number 3. The function is not continuous at x equals 3, and that is evident there. Okay. Number 4. You can already see again the same pattern, just the only difference is it's inverted. You can see that as this comes from the right, I'm reaching a limit here. So this is not continuous because it jumps up to another point. And same thing if I come from the left, I'm going up to the value of -3, where c is -3, and you can see that my value is 3. So again, this question you would answer the same way. You would say for part A, the limit as c approaches -3 from the right. So as c approaches -3 from the right, so you're coming up, you would answer yes, the limit is 3. Going across on the cursor, as you can see, that's the 3. As x approaches 3 from the left, same difference. You're coming up, you see you end up here. So yes, at this point the value is the limit as x approaches 3 from the left hand side is 3. And again, we're still at the 3. And for the last part, part C, where it just simply says, well, as it approaches a -3, then what is the value? And still our answer is still 3. In this case, the function is not continuous at x equals -3. Because at -3, the value for this is actually 4. Okay? Notice that for this one, the actual value when x is 3 was actually 1. Yet when we fulfill this part of the equation for analysis from the left to the right, we get 3, 0. And 0 being our answer to the limit of. So that's number 4. Let's take a quick look at 5 and 6. Okay, and you can see again, if you recall from section 2.2, ET doesn't phone home here. ET's fingers never touch. So for question number 5, the limit as you approach, as x approaches 2 positive, from the right we get -3. As x approaches 2 from the left, we actually get +3. However, for C, as the limit approaches 2, you would answer the limit does not exist. The limit does not exist, and the function is not continuous at x is 2. You might want to rewind and revisit that explanation. Okay, look at number 6. Number 6, we're looking at the limit of f of x as we approach -1 from the right. As we approach -1 from the right, we see that the limit is 0. from the left as we approach the limit of -1, or excuse me, the limit as we approach, x approaches -1 from the left, going this way, is 2. You can see right here, that's the cutoff, right? However, if we're looking at just simply the -1 and just focused on just this line here, we would say, in this case, the limit does not exist. Remember, ET's not phoning home. The two fingers are not together, the finger points. So they're two separate areas. So here you would argue the function is not continuous at x equals -1.